I'm Ishjan. Today, me and Zihan are going to explain 6 physics concepts related to a bicycle.
Using our bike, we're going to demonstrate centripetal force, the conservation of momentum, or how the impulse equals the momentum over time, friction of different tires, linear versus rotational speed, aerodynamic drag, and the center of gravity.
Have fun! I'm Ishjan. Me and Zihan are currently going at the same speed on our bikes. Now, we're going to start coasting. As you can see, Zihan's bike is rolling much further than mine in just the short period of time at this low speed. This is because Zihan's tires have lower rolling resistance because they are narrower and have less tread than my thick, knobbly tires.
At this speed, air resistance is pretty much negligible, so we can attribute the further rolling to not less air resistance, but to the the smaller contact patch.
This means that Zihan's tires have a lower friction coefficient than mine. Explain that.
The coefficient of friction, force of friction is equal to the coefficient of friction times mass. And given how we're roughly the same mass, this bike experiences far less friction due to rolling resistance.
Hi, Miss John. This is the normal riding position on a road bike. As you can see, the handlebars are extremely narrow, and when Zihan and the riding position of a road bike forces you to sort of lean over the handlebars, which minimizes the area the wind can hit you.
This means at high speeds, the amount of force you need to overcome the aerodynamic drag is far less.
That also means that road bikes like Zihan's are a lot faster and more efficient on hard surfaces than mountain bikes like mine. Now, as Zihan gets onto my mountain bike, you can see that the riding position is far more upright, and the handlebars, which are optimized for handling instead of aerodynamics, are a lot wider. But what this does is that all this wind can hit Zihan and make it really inefficient to ride.
Here, Dylan's legs are exerting a lot of force in order to get the bike up to speed. But his hands can exert the same, can get the bike stopped. This is even though the momentum required to start and stop the bike are the same, because the change in speed is the same and the mass is the same, and momentum is simply change in speed times mass. Therefore, the impulse, because J equals delta P, the impulse required to start and stop the bike are the same. But because impulse is time, the change in time times the force, even though Dylan's hands are exerting a lot less force than his legs, they can get the same amount of they can change the same amount of momentum because Dylan's hands can do it over a longer period of time to get the bike stopped. The gears on a bike. Even though Dylan's legs are rotating at the same rotations per minute, when he changes gears, the back wheel goes faster and faster. This is because the gear ratio is different. The chain is connected to, when the chain is connected to a smaller gear, it means that Dylan needs to put in more force in order to move at the same speed, but it also means he can achieve a greater speed.
The centripetal acceleration is the reason why I was able to complete that turn without falling over or flying into the house across the street. This is the force that glues my tires to the pavement, which keeps me from sliding out or going on a tangential line to the circle.
The centripetal force acts against the inertia because the bike wants to go forward because of inertia. However, centripetal force is able to counter that and keep the bike on a turn. Okay.
Hi, Miss John. Center of gravity plays a huge role in biking, especially bike tricks. So what I'm doing now is a track stand. I'm trying to stay perfectly still and balanced at the same time. As you can see, I'm making small adjustments to my center of gravity to keep the bike balanced by twisting the handlebars or by rolling forward slightly. This same principle of center of gravity can also be applied to a wheelie. In a wheelie, I'm shifting my body ever so slightly from side to side on the seat so I can stay balanced on my rear wheel and not fall over either left to right or forwards to backwards. In addition, it also helps with the stoppie. In a stoppie, I have to be careful to regulate my center of gravity with the front brake so I don't flip over the handlebars and get seriously injured. I also have to keep my weight strictly over the center line of the bike to preserve a good center of gravity so I can stay balanced. That'll be it, Miss John. I hope you enjoyed Physics of a Bike with Dylan and Zihan. Have a nice winter break.